All right, so today we're going to continue our introduction to trigonometry, and we are going to start with quite possibly the absolute most important thing of the entire course in Precalculus, called the unit circle. All right, um, you will be expected to know this inside and out, not just for this class, but when you get to calculus as well. Okay, so this is what the unit circle looks like blank. All right, so um, let me make this a little bit smaller so we can see the whole thing. What's that? No, I actually can give you blank ones. Okay, so this is a blank unit circle. All right. Um, like I said, this is incredibly important for this class. Absolutely. All right. So throughout the next 4 units, um, which are all trig, right? So we're going to need to know this for all of them. Um, you're going to have 3 different quizzes over this. All right. The first quiz will be announced. Like I'll give you notice, right? I'll say like, okay, next Tuesday or whatever, you're going to have a quiz. All right. So I'll give you a couple of days notice on that one. The ones after, however, all right, will just be kind of pop quizzes. All right. They'll each obviously count as their own quiz grade. However, the unit circle is so important, all right, that after your third quiz, I will also take all 3 of those quiz averages and make it a test grade as well. Okay, so unit circle super super important. However, it's not near as hard. I'm not just gonna fill this thing in for you and say here stare at it for 37 hours and memorize it. Okay, there's lots of little tricks and things that you can use to build it. Okay, and which I'll do. All right. I still don't have this thing memorized. I just know how to count. Okay, like basically, if you can count by certain things, then you'll be able to fill this in relatively easily. Okay, so we talked about yesterday radian measure and of course degree measure. Okay, and each one of these, all right, is an angle, right? So remember in standard form, we start from the positive x-axis. So this line creates one angle with the positive x-axis. This line creates a different angle. This line creates a different one. This one's obviously a 90-degree angle, right? And so on and so forth. Every single line creates a different angle with the positive x-axis. All right, now on the papers I just gave you, which one of the blanks has degrees in it? Is it the inside or the outside one? The outside? Okay. Okay, no problem. All right, so I'll start with degrees because that's typically what we're most familiar with, and most of us are more comfortable with degrees. Okay, so of course, here we're at 0 degrees. All right, now the trick for this, I wish I could get my pen thin. Hmm. Really aggravating. Okay, well, whatever. All right. The kind of trick for the degrees, it's actually really easy. See how sometimes there's this big gap between lines, and then other times there's a little gap? Right? Anytime you go a big gap, you add 30. Anytime you go a little gap, you add 15. Yeah, that's it. So this one here would be 30 degrees. Then we have a little jump, so we would add 15 to get to 45 degrees. Yep, then 60, because we add 15 again. Then a big jump, so we add 30 to get to 90. Another big jump over here, so we add 30 again, 120 degrees, absolutely. A little jump. Another little jump. Yep. And then a big jump. Exactly. All right, another big jump. 210. A little jump. Another little jump. A big jump. Another big jump. A little jump. Another little jump. And then a big jump. Right. So 360 and 0 are like we're at the same spot. Remember how we talked about coterminal angles yesterday? And to find any coterminal angle, you just add 360 degrees essentially. So 0 and 360 are coterminal angles. Okay. All right. So pretty simple, right? I mean, that really doesn't take any memorization, I don't feel, right? You just add 30 or add 15, right? So no big deal at all. Right, absolutely. Okay, so now we're going to talk about radian measure, all right? And we talked about yesterday how to convert, right, from degrees to radians and from radians to degrees, okay? Well, 0 is really easy. It's still 0. Yeah, right, it doesn't matter. So, of course, if we're going from degrees to radians, we would be multiplying by pi over 180, right? So, of course, 0 degrees times pi over 180, it doesn't matter. 0 times anything is 0, right? So, we don't really have to worry about all of that, all right? But now we can do 30, all right? 30 divided by 6, right? Yes. Yeah. So, of course, these will cancel. 3 divided by 18, 3 over 18 reduces to 1 over 6. So this is pi over 6. All right, now, these quizzes that I give you are going to be timed, right? You don't just have an hour and a half to fill in a very simple unit circle. So you're not really going to have time to go through and convert every single one of these. However, again, if you can count, it's not really a huge deal, okay? So I know that every 30 degrees is 1 pi over 6, okay? So now I'm not going to...
Does that mean the next one's going to be pi over 3?
Well, yes. And now, when we do this, we're only counting every 30 degrees, right? So we're kind of skipping all of these middle lines, right? So this is pi over 6. All right, now if I jump 30 again, I'm just going to count by pi over 6s. So this is 1 pi over 6. I jump 30 degrees more. Then I have 2 pi over 6, which reduces to pi over 3. I jump 30 degrees more. I have 3 pi over 6, which reduces to pi over 2. 4 pi over 6, which reduces to 2 pi over 3. 30 degrees more. 5 pi over 6, which doesn't reduce. 30 degrees more. 6 pi over 6, or just pi, which we should know, right? 180 degrees is equal to pi. 7 pi over 6. 30 degrees more. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6, which reduces to 5 pi over 3. 11 pi over 6, which doesn't reduce, and 12 pi over 6, which reduces to 2 pi. Again, of course, in radians, coterminal angles, we add 2 pi. So, of course, 0 and 2 pi are coterminal angles. Okay? So now we're just missing these kind of middle ones. Okay?
Pretty much we just count.
Yeah, you just count, right? So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. And you just reduce. I mean, again, right? I don't expect you to memorize all of this stuff. Just count, right?
So every 30.
And so every 30 degrees is 1 pi over 6. Absolutely. Absolutely. Okay, so now the first piece we're missing here is 45 degrees. Well, let's go ahead and do 45 degrees times pi over 180. All right. Well, 45 goes into both of these. 45 goes into 45 once. 45 goes into 180 4 times. So this is simply pi over 4. All right, so this is pi over 4. Now, there's a couple of different ways that you can think about this. All right, we can essentially do the same thing. We can count every 45 degrees as 1 pi over 4. All right, so this would be 1 pi over 4. This would be 2 pi over 4, but we already have it, right? We've already done it, so we don't have to do it again. This would be 3 pi over 4. 45 degrees more would be 4 pi over 4, but we already have it, right? Then we would have 5 pi over 4. 45 degrees more down here would be 6 pi over 4, but we already have it. 45 degrees more would be 7 pi over 4. And then 45 degrees more, 8 pi over 4, but we already have it. Okay, so you can think of it as counting by pi over 4s, but we'll already have half of them. Or honestly, how I think of it is all of the remaining ones are just the odd pi over 4s, right? So 1, 3, 5, 7. So 1, 3, 5, 7, like the only blanks that you'll have left after you do the counting by pi over 6s. Does that make sense? Okay. Again, of course, you could just count by pi over 4s. There's 40.
Do 1, 3, 5, 7.
Yeah, 1, 3, 5, 7. So, I mean, that's how I think of it. It's kind of easy that way. Okay, so now we're done with all of the angles. All right. And honestly, that's kind of the harder part, and I'll show you why, because the points are actually quite easy. Okay, so now what's really important here is this is called the unit circle, not just because they wanted to call it the unit circle. All right, this is called the unit circle because its radius is 1. Okay, so like from here to here is 1. From here to here is 1. Right? From here to here is 1. Okay. Well, all the radii are right. So now all of these points, these are x, y coordinates. Okay. Now think of this as the origin. This is 0, 0. So if I go 1 unit over here, what would be this coordinate?
1, 0.
1, 0. Yeah. All right, what if I start from my origin again, 0, 0, and I go up 1 unit?
1, 1.
Not 1, 1, 0, 1, right? Because we haven't gone to the right any, right? The x coordinate tells us how far left or right we go from the origin, correct? So this is just 0, 1, right? I didn't go right or left any, and I went up 1.
Oh.
You know what I mean? Gotcha. All right, what would this point over here be? Negative 1, 0. And what would this point down here be? 0, negative 1. All right, so those are fairly straightforward, right? I mean, you don't really have to think a whole lot about those. Okay, now, all you have to really do is remember this first quadrant, and then everything will just reflect. And we'll talk about that earlier. Okay, so now all of these are going to be fractions. You can just make them all fractions. And the denominator for every single one is going to be 2. Every numerator is going to be a square root. Okay, now, I start with the x coordinates, and I count backwards from 3 as I go up. 3, 2, 1. And then you do the same thing coming back down for the y's. 3, 2, 1. And that's it. We're done with all of this. All right.
Who made this up? I don't like. You get that?
Well, where this actually comes from, which I'll let me kind of get through all the actual points and stuff, and then I'll explain where it comes from. And you've seen it all before, right? You've seen it all before in geometry, which you just.
I was on math and I clicked on one of them and I saw that one of the answers was square root of 2/2.
Right. Yep. And it all comes from here, and I'll show you where it all comes from. Okay, now all of these other points are going to be the same, just with different signs. Okay, now remember, in the first quadrant, both your x and your y coordinates are positive, right? In the second quadrant, your x coordinate is negative, your y coordinate is positive. In the third quadrant, both your x and y are negative. And in the fourth quadrant, your x is positive, your y is negative. Okay, now all you have to do is reflect and use the same points for the reflection and just make sure that you have your signs correct. Okay, so for instance, this point over here is this point reflected across the y-axis. Agreed? Well, it's going to be, so I'm using this point, right, because it reflects over here. Now, what's the square root of 1? 1. You don't have to put the square root here. So this is really going to, now remember, the x coordinate here is negative. So this is going to be negative 1/2. My y coordinate stays positive, so square root of 3/2. Right? This point here, if I reflect it across the y-axis, is going to be this point over here. Again, my x coordinate, so I use these same two numbers, but my x coordinate is going to be negative. So negative square root of 2/2, positive square root of 2/2. Same thing here. I reflected this point over. All right, so I'm going to get negative square root of 3/2, 1/2. Done with that quadrant.
Are we good to just put a square root around 1? So
yeah, you can. Yeah, if you want to leave the square root there, that's perfectly fine. Do be very careful. I have had students make the mistake of putting the negative under the square root, right? Please don't do that, right? And don't put a negative outside the parentheses, right? When you're talking about ordered pairs, right? If it's a parentheses for algebra and you want it to be distributed, that's perfectly fine. But that's not how ordered pairs work, okay? So do make sure that the negatives are inside the parentheses. Okay, so now we're going to kind of do the same thing, except now I'm going to reflect across the x-axis, okay? So, and now they're both going to be negative. So this point right here is going to be this point right here. So negative square root of 3/2, negative 1/2. All right, my middle point will be reflected down here. Negative square root of 2/2, negative square root of 2/2. And then my top point here will be reflected as my bottom point here. So negative 1/2, negative square root of 3 over 2. And then for my last 3 points, we do the exact same thing. You can either reflect these points across the y-axis, or you can reflect these points across the x-axis. Doesn't matter. I'll do these ones across the x-axis. So I'm going to take these points here and put them down here. My x is positive, my y is negative. So this will be square root of 3 over 2, negative 1/2. Take my middle points here, reflect them down here. So square root of 2 over 2, negative square root of 2 over 2. I wish my pen were a little bit thinner. These would be a little bit more legible. And then my top point up here becomes my bottom point down here. So 1/2, oh, son of a biscuit. All right, so 1/2 and negative square root of 3 over 2. And that's it. That's our unit circle. It's done. It's filled in. Okay. So really, there's not really a whole lot of memorization that needs to be done, right? You can just add 30 and 15 to get all of your degrees. Start at 0, count by pi over 6s every 30 degrees. Then you can either count by pi over 4s every 45 degrees, or just do your 1, 3, 5, 7 pi over 4, however you want to think of that, right? These are the very basic like points on, your x and y axes, right? Just a coordinate grid. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. All right. And then here, all of our denominators are 2. All of our numerators have square roots. Start with your x, 3, 2, 1. Come back down, 3, 2, 1. Reflect everything. Make sure your signs are appropriate for whatever quadrant you're in. And you're done. That's it. All right. Now, this whole multiple units is called trigonometry. Does anybody know what the word trigonometry means?
Something 3.
Something 3.
Geometry, triangles.
Essentially, the study of triangles, right? That's what trigonometry is, the study of triangles, right? Well, if we're studying triangles, why are we worried about a circle?
Because there's triangles in the circle.
There's tons of triangles in this circle, okay? For instance, I guess I'll use a different color here to not, get this messed up. So if we think from here to here, and then drop a perpendicular down to the x-axis, if we think of this triangle right here, all right, and just to kind of okay, so if I just kind of move this triangle out here, just so that I don't have to mess all of this up.
Well, we know that it's 30 degrees.
Right. So we know that this is 30 degrees, or pi over 6. It's the same thing. All right. Which means, and we know that this, since we dropped a perpendicular, we know that this is a 90-degree angle. So what is this here?
So that has to be
60, right? This is a 30, 60, 90, which is one of the special right triangles that you learned in geometry, okay? Now, think about what coordinate pairs here mean, all right? We know that this is the unit circle, so my radius is 1, which means my hypotenuse here is 1. The x-coordinate tells me how far from the origin I go to the right, so this would actually be the square root of 3 over 2. And then the y-coordinate tells me how far I go up, so this is actually 1/2. All right, and so you've studied 30, 60, 90s and 45, 45, 90s in geometry, all right? And you were taught like proportions, right? You would say, okay, well, if this side is s, then this side is 2s. Of course, 2 times 1/2 is 1. And this side was the square root of 3 times s. Yes?
How do you get the, like, how do you know when it's like the square root of 3/2? Like, how do you get that?
Okay, because when we first learned just on coordinate grids, right?
Yeah.
Right? The x coordinate tells us how far right or left we go, and the y coordinate tells us how far up or down we go. Well, for this point right here, my x coordinate is square root of 3/2, which tells me from the origin I had to come to the right square root of 3/2. Does that make sense though?
Yes, sir.
All right. And then my y coordinate tells me how far I have to go up.
Right.
So I had to come up 1/2. Does that make sense? And you can do this for absolutely any triangle on here, right? In fact, the 60-degree triangle is going to be exactly the same as this, just different, right? And instead of this angle being 30, it's going to be 60. And instead of this angle being 60, it's going to be 30, right? And then, of course, 45, you would have a 45, 45, 90 right triangle. Does that make sense? So there's tons and tons of triangles inside this unit circle. Cool beans? So that's what these numbers are, right? These numbers are actually, okay, what is this side of a triangle and what is this side of my triangle? Make sense? Okay. So, and if you understand that concept of it, then it's a lot easier. So just to get all of this stuff out of here. Okay. So, but anyway, here's our unit circle. Okay. Now, a couple of things that you may want to write on your unit circle. And for those of you at home, I can give you, a blank unit circle when you come to school tomorrow. If you want to watch this video and kind of fill it in again some other time on your own, you can do that. Or if you were motivated enough to draw your own circle and stuff, more power to you. All right, but something that you may want to write on your unit circle paper, because until you're incredibly comfortable with this, you're going to want this in front of you when you're doing homework, when we're in class going over new stuff. All right, we're going to use this all of the time. Okay. Now tomorrow we'll talk about the trigonometric ratios that you learned in geometry, right? Everybody remembers SOHCAHTOA, hopefully, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, well, if you forget, there's a giant poster in the back of my room that goes over all of that stuff. All right, so SOHCAHTOA will be very important. We'll go over that in a lot more detail tomorrow. All right, but it's really important to know that for any angle theta, all right, sine of theta is equal to your y coordinate on your unit circle. All right, cosine of theta is equal to your x coordinate on your unit circle. And tangent of theta is equal to the y coordinate divided by the x coordinate on your unit circle. All right, so for example, if I asked you, what is the sine of 210 degrees? All you have to do is come down here to 210 degrees. We know that sine is the y coordinate. So the sine of 210 degrees, yeah, that's it. That's all you have to do. All right. So if I ask you, what is the cosine of 7 pi over 4? You come down here to 7 pi over 4. Cosine is my x coordinate. So you'd say, oh, that equals the square root of 2 over 2. Does that make sense? Hopefully. a little bit. Okay, so what I'm going to do now is go back around the unit circle and put the tangents. Okay.
You said the cosine of 7 pi over 4 would be
Square root of 2 over 2,
okay.
because it's your x coordinate. Yep. Mm-hmm. Okay, so if we're looking at this thing again, and I'll do my tangents in red. Now, when I quiz you, all right, you will never have to write the tangents on it. Okay. You can always get the tangents just from taking your y coordinate and dividing it by your x coordinate. Simple enough. All right, but there's really only 3 things that you have to remember, and then just like all of the other ones, they just kind of reflect around. Okay, so for pi over 6, or 30 degrees, right, same thing, depending on whether you're talking about degrees or radians. All right, to get the tangent, you do the y coordinate, which is 1/2, divided by the x coordinate, which is square root of 3 over 2. When you have a fraction divided by a fraction and they have the same denominator, you can simply cancel out those denominators. So this is really just 1 over the square root of 3. However, it's improper in mathematics to have a square root in the denominator. So we have to do what's called rationalizing, which means we have to multiply the top and bottom by that square root. And when you do that, you end up with the square root of 3 over 3. Okay? So the tangent of 30 degrees, or the tangent of pi over 6, is the square root of 3 over 3. All right, doing pi over 4. Well, here we're doing the square root of 2 over 2 divided by the square root of 2 over 2. What is anything divided by itself? What's 4 divided by 4? 1, right? Anything divided by itself is 1. Doesn't matter what that thing is, unless we're talking about 0.
Question. What do we do to get square root of 3 over 3?
I took this and I divided it by this.
Yeah, I get that, but like then you have square root 1. Or 1 over square root of 3.
Let me get some more room to show again. Okay, so we have 1/2 divided by the square root of 3 over 2. So these cancel. So now I'm just left with 1 over the square root of 3.
Right.
Okay, we're not allowed to have square roots in the denominator.
Right.
So I have to do what's called rationalizing, which means I multiply both the numerator and denominator by the square root of 3. Okay, so now, of course, 1 times the square root of 3 is just the square root of 3.
Yeah.
All right, the square root of 3 times the square root of 3, there's a couple of different ways that you can think about it. When you multiply square roots, you're allowed to multiply what's under the square root. So this would be the square root of 9, which is just 3. All right, or actually how I think about it. Yeah, how I think about it is whenever you multiply something by itself, what are you really doing? Squaring it, and squares and square roots cancel out. Right, so this is like the square root of 3 squared. Well, that's just 3.
Right.
So that's how I got the square root of 3 over 3. Make sense? Okay. And then we're okay with anything divided by itself as just 1 here. Okay, so now we just have this. All right, so now we'll have the square root of 3 over 2 divided by 1/2. Well, again, my 2's cancel. This is just the square root of 3 over 1. Just the square root of 3. Absolutely. All right, so whoops. So this is the square root of 3. I guess I should have went ahead and kind of did this also. What is 0 divided by 1? 0. What is 1 divided by 0? Undefined.
So we're supposed to know all the tangents for everyone?
No, you don't. You're not going to have them memorized. Like, I'm never going to test you on it. I mean, I'm never going to quiz you like on the unit circle quiz. Now, on a test, I might ask you, what is the tangent of pi over 4, right? Now, on tests, I will allow you to use a unit circle. Typically, what I do is I'll give you your first unit circle quiz before the first trig test, and then I will grade it, and I will let you use the graded quiz on your test. So you'll have a unit circle in front of you. And if you missed something on the unit circle, you'll know that you missed it, and there's really only so many things that you could have missed on it, right? Like you're going to have a unit circle in front of you. So getting that stuff won't be difficult. All right, now from here, we just kind of reflect. All right, so here, I do my y divided by my x. So it's going to be the same as here, but a positive divided by a negative is a positive. Is a negative. Sorry. So this will be negative square root of 3. Reflect this over, it'll be negative 1. Reflect this over, it'll be negative square root of 3 over 3. All right, this is still going to be 0. All right. Reflect this down, but now a negative divided by a negative is a positive. So this will actually be square root of 3 over 3. This will be positive 1. This will be positive square root of 3. Reflect it over. Well, this will be undefined again. Reflect this over, but now a negative divided by a positive is a negative again. So negative square root of 3, negative 1, and negative square root of 3 over 3. Again, you won't be required to put those tangents on there when you take your quiz. A lot of students do, just so that they have it on there when they have their test, but you don't have to. It's not going to be graded. No, I don't do extra credit there, but it's just nice to have it on there, especially since you can use it on your test. Okay, now this is kind of what I already talked about, where sine is the, I call this theta because I typically do. All right, but sine is your y coordinate, cosine is your x coordinate, tangent is your y divided by your x coordinate. All right, now, these you may or may not have seen in geometry. I know Kelsey did, because, I taught it in geometry, mainly because I teach all the honors precalculus classes, so I know what you're going to need. So I kind of tailored my geometry when I taught geometry honors. I tailored it to my pre-calc class, like what I knew you were going to need in pre-calc. So, but a lot of you, if you didn't have me for honors geometry, may not have seen these trigonometric functions. Okay, this is called cosecant, secant, and cotangent. Okay, now all these three are the reciprocals of these three. Okay, so sine and cosecant are reciprocal functions. All right, cosine and secant are reciprocal functions, and tangent and cotangent are reciprocal functions. Of course, reciprocals, you just flip the fraction, right? So if this is y over 1, this is 1 over y. If this is x over 1, this is 1 over x. If this is y over x, this is x over y. So you just flip it.
Are we gonna do we tomorrow?
Tomorrow, yes. Yeah. Tomorrow and Thursday. And then Friday you'll have a quiz. Monday we'll have one more lesson, Google Meet. Tuesday you'll work on the review. Wednesday I'll go over the review. Thursday will be the test, next Thursday, because that's our last day before spring break, because we don't have school that Friday. But it works out timing wise perfect.
Are we gonna be back full time?
Probably not till after spring break. Yep. Okay, everybody got Everybody got these down? Had enough time? What's
Is
that?
it on paper?
Yeah, it'll be on paper. Okay. Yes, sir. Oh, yep. Yep, no, not a problem. Good. Awesome. Okay. So basically, this is all we're kind of doing for the rest of the day primarily. All right. So if I want to find the 6 trigonometric functions of each of these, okay, so I want to find first the sine of pi over 6. Well, all you have to do is go to pi over 6. Sine is my y coordinate. All right, hopefully you still have a unit circle in front of you. So pi over 6 is here. My y coordinate is here. So that's just 1/2. All right, well, we know that cosecant is just the reciprocal of sine. What's the reciprocal of 1/2?
2/1.
Yeah, which is just 2. Yeah, absolutely. All right, so now we can do the cosine of pi over 6. So now you go to pi over 6 on your unit circle, the x coordinate, which is the square root of 3 over 2. All right, we know that secant is the reciprocal of cosine.
So 2 over square root of 3, but you can't have that,
right? Right. So then we're going to have to rationalize. So multiply both sides by the square root of 3, or sorry, numerator and denominator by the square root of 3. And we're going to get 2 square roots of 3 over 3.
Wait, why'd you put pi over 2?
I'm sorry, pi over 6. Yeah. All right, now we can do tangent of pi over 6. All right, that is the y coordinate divided by the x coordinate, but we just went over all of those, right? So we look at pi over 6, and it was 1/2 divided by square root of 3, so it was 1 over the square root of 3, and we rationalized, and we got square root of 3 over 3. All right, cotangent is simply the reciprocal of tangent. So 3 over the square root of 3. All right, so we have to rationalize. We get 3 square roots of 3 over 3. What happens here?
3 cancel.
Yeah. All right. And you don't have to show me this every time, right? If you just think about it in terms of our unit circle, right? Here we did 1/2 divided by the square root of 3 over 2, and we got square root of 3 over 3. Here we flipped it. We had the square root of 3 over 2 divided by 1/2, which was the square root of 3. So these things are just reciprocals, so you don't necessarily have to show me that rationalization. Make sense? Okay, try this one, right? Give me all 6 of the trig functions again. Sine, cosine, tangent, which will all come straight from our unit circle. And then cosecant, secant, cotangent, which we just flip. All right, guys, so we can go ahead and take a look at this. We've had enough time. All right, so 5 pi over 4, again, if we go back to our unit circle, all right, 5 pi over 4 is right down here, this middle point here. All right, so both my x and y are negative square root of 2 over 2. So my sine will be negative square root of 2 over 2. And my cosine will be negative square root of 2 over 2. And tangent, of course, y divided by x, or sine divided by cosine. Anything divided by itself is 1. And of course, the reciprocal of 1 is also 1.
I looked at the wrong one.
Slacker. All right, so we do have to be careful about that because of the way that, like, if the way that we write on them, sometimes we need to make sure that we're looking at, the correct line. It's very easy to, depending on how we wrote on them, to confuse them. All right, so here if we want to reflect this, flip this, we're going to have negative 2 over root 2. So then we rationalize, and we get negative 2 root 2 over 2. Of course, these 2's cancel, and we just have negative the square root of 2. And this is the exact same thing. I don't need to show all of that work again. So there we go. Yes, sir.
What is the
The what log? The cotangent?
Yes.
Cotangent is just the reciprocal of tangent. So it would be the x coordinate divided by the y coordinate. Yep. Of course.
It's going to be the same thing for the next one, right?
Mm-hmm. Try this one. And this one's quite easy where it's at.
And then the cotangent is 1, right?
For which one? Oh, yeah, for that last problem? Absolutely. Yep. Because the reciprocal of 1 is 1.
Isn't it just going to be the same thing on the other side?
As what other time?
Like both of them are going to be the same number.
Not exactly, but some. Yeah, I understand kind of what you're thinking. Yes. Okay. So we can go ahead and take a look. Okay. So now we're looking at pi. All right. All right. So pi is over here. So my x, which is cosine, is -1. My y, which is uh, sine, is 0. All right, so this will be 0. This will be -1. All right, the tangent, which is the y divided by the x, is 0. Absolutely. All right. Now, cosecant, all right, think of this as 0 over 1. If I flip that, what do I get?
So 1/2.
Which is what? Undefined. All right, now the reciprocal of -1 is still -1. And again, tangent was the x divided, or I'm sorry, was the y divided by the x, so 0 divided by -1. Cotangent is the reciprocal of that, so -1 divided by 0. Again, whenever you divide by 0, you are undefined. Does that make sense?
So 1/0 was undefined.
Right. Whenever you divide by 0, you would get undefined. Okay, so now this is a little bit different, all right? Um, because do we have any negative angles on my unit circle?
No.
No, right? There's a couple of ways that you can think about this, okay? Now, yesterday when we talked about angles, we said, okay, as you go counterclockwise, these are positive, correct?
Right.
If I go clockwise, all right, then my angles are negative. All right, so it said, what was it, -pi/3? Okay, so positive pi/3 is here. Stop it. All right, so positive pi/3 is here. Well, what if I start at the same place here and go negative the same amount of space? This is -pi/3. All right, so -pi/3 and 5pi/3 are really the same thing. Does that make sense? Remember how yesterday we talked about coterminal angles and we said, okay, well, if we go positive a certain amount, we can go negative and still get to that same spot. All right. If you don't like that, and a lot of students don't like that, going in the negative direction, all right, that's fine. Find a coterminal angle. How do we find a coterminal angle?
Add or subtract.
Add or subtract what?
360.
360 for degrees. What about for radians?
5/2.
Not pi/2.
2pi.
2 pi. 2 pi is the once around the one full revolution. So I just add 2 pi to this. Okay, well, -pi/3, I'm going to need a common denominator here. So 6 pi/3. What do we get? 5 pi/3.
So like,
right? So
we see that, like what you did, and then we did the 60, and then we did it the other way. Could we just put that -pi/3 equals 5 pi/3?
Absolutely.
And then just go from there?
Yeah, absolutely. And that's how I think of it. Like, I actually just visualize going that same distance in the negative direction, as opposed to going through this process.
But like on the test, are we good to put like 5 pi/3, or do we need to put sine -pi/3?
It wouldn't matter to me, honestly. On the test, I'll call this theta. And I don't even care if you write it in there, right? If you just say, okay, well, I know theta is equal to -pi/3, which is the same as 5 pi/3. But if you just tell me sine of theta equals blank, You know what I mean? Like you can just write the theta in there. Now, sine does have to have all trig functions, have to have an argument, right? Don't just say sine equals. There has to be something here. There is no sine without a theta, without an angle. All right, so again, we go back to our 5 pi over 3, and we say, okay, well, my y coordinate is negative square root of 3 over 2. All right, cosine is 1/2. Tangent, this will be negative square root of 3. So then cosecant, all right, we flip that. So we're going to have negative 2 over the square root of 3, all right, which will rationalize to negative 2 square roots of 3 over 3. Of course, secant will just be 2. And tangent will be negative square root of 3 over 3. Are we starting to get the hang of it? Okay. All right. I say we just skip these.
Yep.
Okay. This is really meant for more when school used to be normal and you were sitting next to people and we could do a little group activity. Okay. So the domain of sine and cosine functions, all right, it's all real numbers. And the reason why is because you can keep going around the circle in either direction as many times as you want, infinitely, right? You can go positive as many times as you want. You can go negative as many times as you want. Remember, we talked yesterday, and even today when we filled out the unit circle, how, when we're talking about degrees, 0 and 360 are really the same thing, right? They're just coterminal angles. Just like when we just did negative pi over 3, that was the same thing as 5 pi over 3, all right? The range, however, of sine and cosine, all right, let's look at our unit circle. All right. For the x's, and we can think of this as an actual x and y grid, right? So what is the farthest, what's the lowest this graph goes and what's the highest this graph goes?
1 and negative 1.
Yeah. All right, so that's actually going to be our range for sine and cosine.
So 1 and negative 1?
Yep, inclusive. Negative 1 to 1, including both.
Why does it have to be those?
What's that?
Instead of like,
because it actually includes negative 1 and 1, right? Like if I do the sine of pi over 2, I get 1, right? It's like when it's the parentheses, it goes all the way up to it, but doesn't include it.
Gotcha.
We actually include 1 and negative 1 here because we can get them when we plug in various angles. Okay, the definition of a periodic function. Don't really worry about writing this down. We're going to start tomorrow with this exact same slide, and we'll go over it in a lot more detail tomorrow. All right. But basically, a periodic function is just a function that repeats itself over and over. Okay, and trigonometric functions are periodic. The main reason why is because if you think about that unit circle, right, we keep getting these values, we get these values, we get these values, we get all the way around the circle. Well, then if we keep going, we just repeat all of those values again until we get around the circle. And then we repeat all those values again as we go around the circle, infinitely and infinitely. Okay, so that is essentially what a periodic function means. All right.
On the graph, that's necessary for a oscillating wave, right?
Yeah, absolutely. And we'll have a whole unit on graphing them. Absolutely. All right. Obviously, ignore this homework. Your homework is on Desmos. And that is it for the day. I mean, Delta Math. Yeah, sorry. You just mentioned you subliminally put it into my subconscious there. All right. So we will wrap up that video.